In NC-Simul 2023, the optimization module has been revamped with more graphical features and controllable settings. Launch the optimization module and start in the upper left-hand corner of the screen with some initial settings. Decide how often you want NC-Simul to calculate conditions for both milling and turning toolpaths, which G-codes to optimize, and which toolpath sequences in those codes specifically to greenlight. To calculate the force on the spindle during material engagement, specify the material type and empty power of the machine. Turn on the cutting navigator, which after calculation allows you to update the rest stock by clicking anywhere in the G-code file. As a baseline calculation, NC-Simul has determined the maximum radial and depth engagements for each tool sequence, along with the feed per tooth, chip thickness, chip flow, and torque on the spindle. From here, we can optimize the feed rates outside and in material at every motion. At the top, create as many or as few strategies as you wish for milling and turning, air cutting, and adaptive motion. These settings can be imported or exported to or from other projects. In air cutting, for example, you can limit the safety zone of the touched versus untouched material for both retract and approach values. Additionally, tell NC-Simul to turn all non-engagements that are still in a feed rate to a rapid or Fmax, all based on rust material. In adaptive, the feed rate can also be tweaked by improving or limiting the chip thickness produced if it's a hard material, or the volumetric chip flow if it's a softer material. On top of that, you can limit any specific parameter by typing in a value or applying them using the graphs function. For any spike you see in the power of the machine, for example, select the sequence to limit, drag the horizontal bar down in the graphing area, and hit apply. It will automatically write that value into the optimization parameters. Once satisfied, hit compute, and NC-Simul will use all conditions to recalculate all feed rates, in this example, at a distance of every 10% of the tool diameter. By comparing the cut conditions before and after side by side, you will see highlighted in yellow where NC-Simul wants to make a modification. It will also show you the before and active cycle times of the program up to the active current block selected. To see those specific time savings, scroll down in the information window where you can view overall time saved in and out of material, feed rates versus rapids, and the same breakdown on a tool-by-tool basis. NC-Simul is ready to automatically rewrite those feed rates into your program, highlighting in purple where a modification will be made. Simply hit Generate and it will create a copy of the new G-code into the optimization folder, retaining your old code in the tapes folder and creating a new simulation environment to do a final test with the new parameters. To finalize your process, hit Save As, and that G-code can be pushed to the shop floor for production, knowing that you have a collision-free program that has a significant reduction in cycle time with a smoother and more consistent engagement to increase all tool lives.